Welcome, Catie Spivey. We are grateful that you're spending some time with us this afternoon, and we really look forward to catching up. I know that you've known Mr. Simmons before, but before we get to that story, please tell our listeners a little bit about who you are and how you came to be involved with space.
My name is Catie, and I am about a year and a half into my career now. I got my bachelor's and master's degree in mechanical engineering from Portland State University. So got my master's back in 2022. I had to look, and then started at Johns Hopkins Applied Physics Lab, and I've pretty much been interested in space and aerospace. I can remember like I walked in the mall and I was like, I want to paint pictures of things I take, like pictures I take on the telescope. And I saw them in the mall. And so ever since I was little, I was interested in space. So yeah.
So you're a mechanical engineer. For our listeners, like what could they expect a mechanical engineer to kind of do? Like what is your job description, if you would?
Yeah, so there's a lot of different things that mechanicals can do, which is why I think it was a really good fit for me. The biggest thing is design work that I think people would think of, and that is really what was interesting at first. But then we also do a little bit of coding, so a lot of us learn MATLAB and then some Python. And then we also do structures analysis. So FEA is the big one that you hear, finite element analysis, as well as computational fluid dynamics. We can even go into mechatronics, like robotic stuff. Um,
Well,
Trying
let
to
me
think
ask
if
you,
there's
like when
anything.
you say design,
Mhm.
design of what specifically? Engines or
Anything really. So mechanicals are really fun because we can really go into any field that we're interested in. A lot of people hear mechanical engineering and they think of cars, which is really funny when I try to get my car fixed and like everybody thinks I should know what I'm doing and I don't know anything about my car. But yeah, I went into aerospace with mechanical engineering. So when I do design, I can do design on pieces of launch vehicles or pieces of satellites, pieces of engines, really anything that's interesting. Mechanicals are, we know enough of the design fundamentals to go into it.
and the only reason I ask is my son is in aerospace engineering and he keeps telling me he's like, I have no idea like what I'm
Yeah.
interested in. Like he's only just begun, right? He's like, I don't know. I don't know. And I was like, well, they were like, you don't have to do aerospace engineering to work in aerospace. So I'm always trying to like help him understand the different, engineering pathways. And I can never find myself articulating that clearly enough.
Right. Yeah, I want to circle back. Who purchased your first telescope for you? And what was the most interesting thing as a kid you remember finding in your telescope?
So I actually, uh, my parents, both of them got me a telescope and I could never get it to work. But before that, I would make little cardboard telescopes out of like paper towel rolls and everything. And the Science Museum had their like planetarium that I would go to up in Jacksonville. So while I didn't personally have a telescope, I was really interested in everything. And in fourth grade, I had to do a project on a planet, and my planet was Saturn. And that really solidified it for me because I was just fascinated with Saturn and hearing about Galileo. And yeah, so Saturn really has a special place in my heart.
I must have had the same telescope as you because I could never see a thing. It was this
Yeah.
big, long white tube and maybe the moon, like super blurry, right? But
Yes. Yeah.
nothing else. And I was so excited to get
Right.
it. And I was
Yeah.
so let down. I was just
Yeah.
like,
Now, as an undergrad, did you ever take an astronomy class? Was that one of your electives?
I did, yeah. So originally, I first went to school for aerospace engineering, and at the time, I thought, oh, I'll just do an astronomy minor and tack that on. So I took, I think, maybe three classes, and then they got really into the physics and math, and that was a little too much for me.
Right.
So
Well, I'm this old guy and I just took an astronomy class and I just learned about shepherd moons, right? With Saturn's rings. Those are these tiny moons that sweep out where the rings are. And that's why we see the bands of rings on, for instance, Saturn's Saturn's rings. And I just thought that was really cool. So I, of course, immediately when I learn something cool, I take it to my kids in class. So at least my sixth graders know about shepherd moons, even though I only learned about it, sort of as an OG. But I think you could spend lifetimes, just looking up at the stars and us trying to figure things out. So we met, for our listeners, I met Catie, even though thanks to Catie reaching out, I did not know this. She was a camp student when I first started teaching aerospace camp. So 20 years ago, I was probably really bad at teaching camp. I know we did Hohmann transfers and orbital mechanics, and we built model rockets. I think that was a lot. And then we surveyed sort of the private space companies and probably the Constellation program, because that was the NASA program of record. But I think, we met at camp, and then I happened to be at the right place at the right time, and we scored some tickets to an event, and maybe you could share about that.
Yeah, I think I was in, I know you had like your group of like higher level students that got to go, and then I like picked my name out of a hat and got to go with you guys to see one of the last few space shuttle launches, I think it was at the time. I've tried to look at which one it was and I just can't remember. But yeah, we got to go over to Kennedy Space Center and meet some astronauts, which I was so young, so I barely remember much of it. But and then seeing that space shuttle launch, and I think that was when I was like, okay, I want to design these things that go into space.
Right. Was it a night launch or a day launch?
It was a day launch. Yeah.
Okay. So yes, Space Florida was very generous, and there was I just, being at the right place at the right time. Sometimes I guess being lucky or chance is better than being good. And there were tickets available for students to go view shuttle launches from Banana Creek. And that meant you were close enough where you can feel a little bit of the rumble in your chest. And I'll never forget a mom that went with us and had a straw hat, and the flap, the brim of her hat was flapping some, and just wonderful. You have to be there, right? You'll never forget it. No one can take that memory from you. Yeah. So you worked through high school. Now, were you in Florida as a high school student, or had you moved west yet?
Yeah, I graduated from high school up in Jacksonville, and then I moved over to California to start freshman year in California.
Awesome. Were you one of the Stanton or Paxson kids?
Yes, I was Stanton, class of 2013.
Fantastic. Yeah, so you're about 3 years younger than my daughter. Were you friends with Garima Gupta? Or does she a little bit older than you were? She's my daughter's age. I think she went to Stanton as well.
So did you start becoming interested in CubeSats when you were just out of high school, or did that come later when you went to the Portland University, right?
Portland State.
Yeah. It's kind of funny because so I went to Cal Poly, and Cal Poly SLO and Stanford are the two that invented the CubeSats. And so the professor that taught the Aerospace 101 course at the time was Dr. P, who helped to invent them. And so we kind of hear at Cal Poly oh yeah, he made this thing. And so we're kind of aware, but from what I remember, you had to apply to get in the CubeSat program there. And so I remember going to career fair as either a freshman or a sophomore and asking some recruiter, what can I do? And he said, well, join the CubeSat team. And it seemed very intangible. I was like, how do I even go about that? And so I didn't get involved. And then when I made my way over to Portland State, I looked up, I knew I was going to go. So I looked up what are some student groups, and I found the Portland State Aerospace Society, which just happens to have its own CubeSat. And at the time I was like, I really just want to work on rockets. That's what I want to do. So who cares about this tiny little satellite? What could I do on it? And in my second meeting that I attended, someone said, hey, I need someone who can do some CAD work, some design work for this CubeSat. And I was there. And so I said, I'll do it. And then that's really when everything took off for me. So, yeah.
So you took advantage of an opportunity. Yes. I also have to back up a minute and translate some of your California speak to the Dr. P was probably Jordy Puig Suari, right?
Yes,
I mean,
yeah.
it's like saying I know E for Elvis. He was like the Elvis. He and Dr. Twigs at Stanford, they are highly respected creators of this form factor. So you took a class with Jordy, who's retired now, and you mentioned slow, which I always laugh at because my kid uses that a lot. San Luis Obispo, right?
Yes.
Slow to the locals. Did you find now I know you had your dad was in the Portland area, is that correct? Is that one of the draws for Portland State? You were an important part of that program, right? You were there when the first CubeSat from Portland State launched. Is that right?
Yeah, so it's really funny, just like you said, it's just being in the right place at the right time. And so when I joined and I was just working on this little CAD project for a solar simulator, and so I was just making test equipment, and at the time there was just three of us mechanical engineers working on the CubeSat. And then we had an opportunity where so ORSAT, the CubeSat I worked on, is fully funded by just like grants and donors. It's not funded by the school. And so we just had enough money to get 4 interns for the summer. And so I had just been showing up like every week and just doing the best that I could. And so when this time came that they were ready to hire, like they chose me to be the lead mechanical engineer. And so I was really the first one to do that. And I basically like took this bits and pieces little ORSAT CAD and really like made it over and made it something a lot more tangible, and went down to the machine shop, and like we were working with a local machinist and made drawings and like had this thing really machined. And all of the CAD work I did was kind of the fundamental work. And then we got more and more people, and eventually got to send it into space in March of 2022, last year.
So you took the theoretical, right? And then you drug it into the real world. So
Yes.
that's I think anytime anybody gets to create anything in their mind and then make it come alive, that's something special.
You might have said this and maybe I missed it, but what was it testing? What was the mission?
Yeah, so ORSAT's a little funny because the original idea for ORSAT was it was accepted through the CSLI to be a 2U CubeSat. On one end, it has a camera to detect cirrus clouds, and it's going to use that data. We have some partners at different universities that are going to use that data for global climate models. And then the other side is a camera that will so students, specifically in Oregon, will be able to make this handheld ground station for less than $50. And then they can stand in a field, and when ORSAT passes overhead, they can downlink a live video feed of their location. So that was the original ORSAT. And then when COVID hit, we actually got an opportunity, another being put in the right place at the right time. Some space company was looking for a 1U CubeSat to get to ride for free. And so we basically like took this 2U CubeSat, took the most important components that we were testing and put them in a 1U and got to send that to space. So we call it just the beep sat, just to make sure that it works. And because a lot of what we're doing is new, like we designed the structure, that's all unique. We also do Wi-Fi from space, like a lot of stuff that is unique. And so just making sure that that could work was kind of that main mission.
It's cool. I mean, because I never really thought about like when you're, I mean, I know the missions that you've done, but if you are testing, when you say Wi-Fi in space, is that not the norm? Like
No.
like radio broadcasting, right? Is
Well,
how you might
radio is a very broad term, and maybe Catie would like to elaborate on the different wavelengths or frequencies that satellites might use for different purposes.
Yeah, I'm definitely not a radio person. But yeah, I know for ORSAT, there's S-band and F-band are the only things that I know of. But there's a couple, ORSAT uses a couple different antennas. But I know from a mechanical perspective, it's important to like make sure that we work with the RF engineers, the radio frequency engineers, to make sure that their antenna can work while also integrating with the mechanical hardware. So that would
But
be my
you were
view.
saying you used, instead of that though, you
Mhm.
were using Wi-Fi in space. So that's like,
Yes.
I'm just trying to
Well,
understand,
yeah,
like how
Wi-Fi is like something gigahertz, right? It's a certain narrow range that the Federal Communications
okay, so it
Commission,
just falls on a
right?
different end of the spectrum,
And
kind of. Okay.
right, and so depending on how much power you have and how much you can transmit, and whatever license you
But
apply
I mean, do
for.
you use the same satellites that we use here to get what is it? I mean, how do you, you know
No,
what I mean? Like
the
when we think
Wi-Fi you're
Wi-Fi,
thinking of has a much more short range.
Okay,
It's
okay.
short range,
So
like
it's-
inside your house kind of use versus.
well, you know, the
up in
listeners
space.
who are like me are going, how is that? Can I just tap
So-
in from my inner?
So did you have whip antennas, like deployable antennas on ORSAT, or did you have ceramic patch antennas? Because our kids, we use ceramic patch and we talk up to Global Star and Iridium, but you were talking down to the ground. So you probably had a larger antenna array than we had, right?
Yes. So ORSAT, the 2U ORSAT is going to have two different types of deployable antennas. And so the 1U that is up in space has one set of those that we call the turnstile. It's got 3 bands times 4, so in each corner. And the reason why we didn't go with like some sort of patch antenna was because on each of the 4 outer sides we have solar panels, and then the other 2 sides have our end cap PCBs. So our deployable antennas are mounted to those PCBs structurally. And those are really fun to try to design because we wanted to avoid any sort of like hinge mechanism, like anything that could get broken in space. And so we wanted something that could just deploy by its own physical properties, and we settled on tape measures. So if you look at our pictures, the tape measures are just the simple ones that are out there in space. So
Yeah, God bless those bimetallic strips, right?
yes.
The metallic tape measures. So when you say turnstile, is that like the spiral arms of the galaxy that extend out when they're released? Is it?
Yeah.
So the it's like a metal tape
Yeah.
measure that's wrapped. And did you use a monofilament line, the classic fishing line, to restrain your antennas and use
We did.
resistors?
Yeah, and so instead of like wrapping around the satellite, like you'll see some of them do, they actually wrap in on themselves, kind of like fruit by the foot, like you see this the snack rolls
Yes.
in. And so we've got 4 of those, and then we're holding them down by the fishing wire. So
Yeah, so for our listeners, it's the coolest low-tech, high-tech solution to an antenna. Metal tape measures want to have a certain shape, and you can roll them up or fold them up, and you have to physically restrain them because they want to take their natural shape, which is extended. So if you cut an antenna, cut this metal the right length, then you're able to use it as an antenna. And we use a resistor. You can obviously correct me, Catie, if I'm wrong. We use resistors that are touching the wire that's restraining your antenna. So when the time comes to deploy, you simply send current to the resistor, which heats up, melts the wire, and now your antenna can
Just
deploy.
rolls out.
It's
Yep.
so low tech, it's awesome, isn't it?
yeah.
There's nothing more ruthlessly efficient than that, is there?
Yeah, I mean, we tried to. So originally, our RF engineer didn't want to go with the tape measure antennas because then you have to work within those metal properties. And so we tried to do fiberglass, which you can also get to deploy like that, which you can see in some newer spacecraft are doing that. Like I think DART had that. But we just couldn't get the right kind of fiberglass to do it. It was just so
Right.
much more expensive, and tape measures are just cheap
Right.
and good enough. So
Well, I'll share with you our first one. We shared a nitinol hinge off doing the vibe test. So, when you talk about simplifying your design to minimize failure, there's a lot to be said for that. So.
Yeah.
Well, so I'm trying to think back again. So like, were you part of the design process on this? And like, how did it go from the beginning? Did it change a lot from what you had originally designed? And is that like part of the fun where you guys get to assemble everything, see what happens, and then start over again? Is that something that a mechanical engineer would look forward to doing?
Yes, definitely. Yeah. So Especially since we're a student group, what I had inherited came from like different capstones, senior capstones, and different projects that people had done through the years. So you get that a lot where students have tried something and then they leave. And so then you kind of have to figure out what did they do, why
What they
didn't
do,
it work?
right.
And so I basically inherited that where it was fiberglass and it was just, it could stay in this rolled up shape, but it wouldn't deploy. And so we like went down to a local fiberglass shop. We were looking at silicone. We were like we were baking fiberglass in our oven at school and like putting silicone and epoxy and everything on it. I called up the spring company that invented slap bracelets and they sent me
Oh,
some
great, because I was
samples.
thinking, I was like, it reminds
Yeah.
me, like, that seems like almost like what you're doing. That seems like it would have been even better than
Yeah,
the.
it's very
Yeah.
creative. Yeah, there's nothing new under the sun, just how we appropriate
So you
it.
get to like
Yeah.
play, basically. Your job
Yes.
with this part is to play, to figure out
That's
how to make it
awesome.
work.
Before, I don't want time to slip away before I bring up two more subjects. One, your Brooks Fellowship, and then also your work at Johns Hopkins Applied Physics Lab. Could you spend just a little bit of time sharing about your fellowship, which is prestigious, and then your current work?
Yeah, definitely. Yeah. So the Brooke Owens Fellowship is, I think, probably the first one that was made for students in any country who are interested in going into the aerospace industry, and you can be in any major. You just have to be undergrad or have just graduated. And I was a 2021 Brookie, and I got to do my internship. So the Brooke Owens Fellowship will place you in an internship in the aerospace industry. There's this whole process where you do a lot of essays for your application, and then they match you with companies to interview with, and then they'll match you with a final company. And so mine was United Launch Alliance. And then it's just like any other internship, although some companies can do some special things for, we call ourselves brookies. And so I got to do lunch with a Patty Gray Smith Fellow and with Tori Bruno, the CEO of ULA. So that was really fun. And then also through the fellowship, we get placed with a mentor who's in the industry. And so my mentor is Dan Dumbacher, who is the executive director of AIAA. I hope I get his title right. And we still stay in contact today. I'm going to his house to watch a Purdue game next week. Yeah, and so that is really like what gave me so many opportunities, and it's how I got my job at APL. And it's great to just like connect with everyone. When I was at the SWE conference last week, we like some
Hold
of the
on,
brookies came up to me.
You dropped
Oh,
another abbreviation.
yeah.
SWE is?
Society of Women Engineers.
Very good.
I'm just thinking Kevin's not going to get it out of his head that you get to hang out at Dan
Well,
Dumbacher's house.
yeah,
I'm already going to hear about this later.
Well, we talked to Dan. I think he was a Purdue professor, right?
Yeah, but
Yes.
you never hung out at his house.
No,
Yeah.
but I always used to see him when we were on Capitol Hill doing advocacy.
Yes.
That's when we see him. And, you and I may have very well been in the same room one time doing something with AIAA in DC, but please continue. Now, so you're at Johns Hopkins Advanced Physics Lab. And for our listeners, Johns Hopkins history and aerospace goes back to the very beginning, right? The American space program, they were there at the beginning. Tell us what you're working on today.
Yeah, so I can't get too much into specifics, but essentially I'm in what's called the Discovery Program. So it's a 2-year rotation program, and I am almost through my 3rd rotation. So for me, I get to do 4 rotations over 2 years. They just changed it to now be 3 rotations. But they match you with host groups. So the way that the lab is structured is it's a matrix, and essentially like your group is what you might think of as like just different teams in different organizations. And so as a mechanical engineer, I really wanted to focus on trying all the different things that I mentioned earlier. And so I've gotten to do some space stuff like design work, and I also got to do a little bit of MATLAB and coding. And so really getting to try the different things in different fields has been really awesome. And I just really enjoy being at a place that's kind of like a mix between like school and industry, because we are so like focused on innovation that people are still in that like phase of willing to try different things. And so
Good.
it's a lot like when I was working on ORSAT and just being able to try things. Yeah.
Yeah, messy, right?
Yeah.
I think your bio is a really good testament to do good work where you are, and when something comes along, don't
Take
be
advantage.
afraid to spread your wings a little, maybe make a mess and see what happens, right?
Yes, definitely. Yeah.
Well, I know we've come to the end of our time together today, but we always like to leave our listeners with some advice for people who might be thinking, I'm kind of maybe considering this route, but maybe I don't know what to expect. So what advice for our younger listeners or even parents out there who might have young students who are interested in maybe pursuing this route?
Yeah, I think just like the big sum of this conversation is like just take opportunities, like, try things if it seems at all interesting, or a good way to develop your skills, because you might go into it and think, well, this isn't what I want to do long term, but if it's a good way to develop the skills that you need long term, then still try it, because you just never know like what's going to happen down the line.
Well, I
So,
think
yeah.
that's especially important, right? If you don't know exactly what it is that you want to do
Mhm.
within a field, you end up figuring that out because you have tried the different
Right.
opportunities that have come your way. And you go, this one's not for me, but this part is. So
Yeah.
I think that's really, really valuable advice. Catie, thank you so much for giving us some of your time today. And I know that Kevin's going to be keeping in touch with you and for the Wolfpack Kit. So thanks so much.
Thank
Yeah,
you.
definitely.
Thank
All
you.
right. Thank you. All right. Bye.